All right. Hello, everyone. Welcome to the Off by One Security stream. Happy Thanksgiving to those of you celebrating it in the States or elsewhere. Sorry for starting up a few minutes late there. There was a gardener with a leaf blower, like literally right below my window, and I couldn't hear a thing, and it's all you would have heard. So I think they moved, so we're good now. I'd like to welcome back Alejandro Vasquez. If you were here during his first session, I think it was just short of a couple months ago. It was on UEFI bootkits and kernel mode rootkits development. And it was a fantastic technical stream, quite a long stream as well, which is always great because you can go back and Alejandro has done such an amazing job at the first time and even better this time with having so much like prepared and links available and QR codes and everything you need to be able to recreate things. And of course, this will live up on YouTube after we're done here, so you can listen to it slowly as much as you want. But Alejandro, if we'll let you give a little background about what that stream was and how it led us to this stream.
Okay, so hello everyone, guys. We are here again. Well, in the first part of this, kind of series that we are doing here in the By One Security channel related with Bootkits and Rootkits development, well, we demystified the malware. We demystified UEFI bootkits, kernel mode rootkits. We shared a few resources for you to start coding the malware, to start developing the malware. And then we compiled a few proof of concepts. We compiled the UEFI bootkit, we tested it, and we shared a few insights on how to install the malware as well on a physical or virtual machine. And what I have prepared for this second session is the emulation of an APT, right? We're going to install and test the UEFI bootkit and the kernel mode rootkit in a machine that has secure boot enabled and an IDR installed, okay, CrowdStrike Falcon. And that's what we're going to do today, okay? So I just have like 6 or 7 slides. I'm not going to already demystify the malware, okay? We have already done that in the previous session, but I have to, sorry, I have to, throw the basics of bootkits and rootkits, okay? So we're going to start. In the middle of the screen, you see a QR code. If you scan it, it's going to take you to the first part of this series. On the left, you see you can see you can watch the talk Maria and I gave at DEF CON. And on the right is the GitHub repository where I have uploaded this presentation along with the presentation I used in the previous session, okay?
Oh, and I remember one question came up after the stream last time where you showed the dwarf code that was inside the driver.
Yeah, I showed some of the source code of the kernel mod driver. Yeah, but what was the question?
I think it was the symbols. The symbols were like included, embedded into the driver. Was that correct, or am I misremembering?
I don't know. I don't remember the question. I remembered some question related with the technique DCOM, direct kernel object manipulation, but I don't remember the other one. But well, we're going to see the source code now. So if some questions pop up, I'm going to answer them. Okay, so
yeah, if you got questions, please do post them. We're happy to get them addressed. And again, the stream's going to run for a couple hours, so get your questions ready.
Exactly. Okay, so well, sorry, but I couldn't convince Maria to join us today. I'm going to be honest with you, but Maria doesn't want to give any talk and appeared in any podcast until she's fully settled into her new role. She's in the middle of switching positions in the law enforcement unit she works for. So I guess you have to wait to have her here. Okay, just give me, if you want her to be here, go and send her a message through LinkedIn and saying how much do you love her to join us in the stream. Okay.
Perfect. Yep.
Give me just a moment. I need to mute myself. Okay.
Okay.
A moment.
Yeah, and certainly thanks for her helping out with this, even though she can't be here. But for sure, we'd all love to have her on. Definitely.
Sorry, I had some issues here in
No worries.
the room. Okay, so wait, give me a moment. So we're going to start, right? Well, now we have shared. There are like 10 GitHub repositories for you available for you to start coding this malware, but these two are the main ones because ABIS is the UEFI bootkit. You are going to find the complete source code for the UEFI bootkit there, and Bentic is the kernel mod rootkit. So those are the main repositories for you to check, right? I'm not going to redemystify the malware. I'm just going to throw some theory about the malware. Well, when we talk about UEFI bootkit development, what that really means is that we are creating malicious UEFI element, a malicious UEFI element like a malicious UEFI application, UEFI drivers, DXE runtime drivers. And when we talk about kernel mod rootkit development, we talk about develop malicious kernel mod drivers. Okay, and if we want to install the malware, the logic to the installation is the same for both elements. If we want to install a UEFI bootkit, a malicious UEFI application or a malicious DXE runtime driver, we just need to find and exploit a vulnerability in a UEFI element. Signed and vulnerable UEFI application, signed but vulnerable DXE runtime driver. Okay, and it's the same logic for the rootkits. If we want to install a kernel mod rootkit, we just need to find if we want to install a kernel mod rootkit, a kernel mod driver, in fact, a malicious kernel mod driver, we just need to find and exploit a vulnerability in a signed but vulnerable kernel mod driver. That makes sense, right? So that being said, I'm going to explain just a little bit about bootkit and about bootkit development. Okay, I'm just going to explain how a typical UEFI bootkit works because in the previous session we didn't have time to explain that in detail. Okay, so well, you already know that we have shared two bootkits for you to use. The UEFI application, we have got the UEFI application to act as a typical UEFI bootkit, and then a DXE runtime driver that can act as a backdoor for you to drop a rootkit in memory as well. So you have two ways of drop a rootkit in memory. The DXE runtime driver allows you to modify runtime services, some kind of functions that are defined during the boot process. And those functions are available to be called when the user is actually using the machine. So you can create a user mod application to communicate with those modified runtime services just for you to say, hey, I want you to execute something in kernel space. I want you to drop a rootkit in memory. And the UEFI application acts as a typical UEFI bootkit. So it's going to modify everything here, everything related with the boot process, and drops a rootkit in memory as well. So you have two ways to drop the rootkit in memory. Now I want to break down this picture, okay? Just to summarize how the UEFI application works. So here you see like three white pictures, three white images that are associated with the three key files involved in the Windows boot process. Okay, this one doesn't count. So 1, 2, and 3. So the first UEFI binary that is going to be called in when a Windows machine boots is the Windows Boot Manager. Okay, the Windows Boot Manager is a legitimate UEFI application called bootmgfw.efi, and it's located in the ESP, the EFI system partition, in this specific folder, in this path. Okay, the Windows Boot Manager is going to load in memory the next element of the chain, the Windows OS loader, and it's going to pass control to it. The Windows OS loader, another UEFI binary called, well, named winload.efi, that is located here in the C disk in this path. What it's going to do is loading the Windows kernel in memory and passes control to it. So there is some kind of chain of calls in associated with the boot process, right? So how a typical bootkit works is, well, it's what we have code in the UEFI application. The UEFI application that we have developed is going to start in first place. Okay, so we are going to use some script, or just configuring the just we are going to configure the machine, the computer, to start UEFI application in first place. So we start in first place, and what we're going to do is loading the Windows Boot Manager in memory. But we are not going to pass control to it, because we want to modify memory and modify some functions in order to maintain the control of the execution until you reach this point, okay? Because at this point, when the Windows kernel is loaded in memory, we can disable protection mechanisms, and we can drop our rootkit in memory. So what the UEFI application is going to do is loading the Windows Boot Manager in memory, okay? And now every function that is defined in this file is going to be in memory, right? So we're going to locate a specific function like this one that we want to modify, locate the specific function in memory, go into the start of the function, and then pick the first bytes and replace them with an instruction that says, hey, I want you to jump to another address. And in that address, we're going to we're going to have our custom version of the function. Okay, so if we do that, when that function is called, first we're going to execute our custom code, and then we can replace again the first bytes with the original version of the bytes in order to execute the original function. And if we do that, we are not going to break anything. But the point here is that most people don't understand what we are going to code in the custom version of this function. In the custom version of this function, we are going to do the same, the previous thing that we have done. It's like we're going to, because the thing is that the function that we are going to modify is going to be called when this file is in memory. So our custom version can do what we have done. It's like going to memory, because this file is already loaded, going to memory, locate another function that we want to modify, replace the first bytes for an instruction that says, hey, I want you to jump to another address, and in that address we have our custom code. So everything is, modifying memory, curating our custom version of functions in order to jump and always maintain code in memory that it's going to be called at some point. And doing that, we can reach this point, the point where we have the Windows kernel loaded in memory. We disable protections, we drop artifacts, we can do whatever we want. Okay, that's how a typical UEFI bootkit operates. And well, the thing is that inside a UEFI bootkit, you just don't there are more like possibilities. Okay, you just don't have to apply hooking and patching techniques and that's all. No, you can go and read the UEFI specification. I don't know if there are like 3,000 or 5,000 pages, but you can pick wherever it says the UEFI specification and translate what you see in the specification to develop your malicious UEFI element with those capabilities, with encryption, decryption, drop something in memory, use whatever protocol you want to communicate with other machines in your local network or on the internet, and you can do that during the boot process before the operating system is even loaded. So that's why so many people say that before the operating system, it's like there is another operating system, because you can do whatever you want using UEFI specification and coding your own UEFI element. Okay, just for you to know. So a typical UEFI bootkit works like that. In the DevCon talk, we break down this picture, so you can. We broke down this picture, so you can just go to YouTube and watch the video if if you don't understand this what I have said. Okay. And oh, sorry, I have some problems here. Give me a moment. I just have to present again. No. Give me no.
While you're doing that, we did have one question from Discord come up saying, with PatchGuard, HVCI, SMAP, driver blacklist, etc., is all this still possible in current Windows 11?
Yeah, we're going to see that.
Perfect.
PatchGuard doesn't detect anything of or bootkit. And wait, I have to close the presentation. Sorry for that.
No worries.
But you're holding down the control key. What the fuck? Just give me a moment. Ever. Okay. Sorry about that, guys. I'm just having some problems with this computer. Okay, sorry.
It's Friday night for you. Demo gods never go to sleep, so.
yeah. Yeah, it's still possible. It's like patchware is not going to detect us, and you can bypass some protections. The thing is that, and I'm going to say that in a moment, that the part that truly matters is the rootkit. And if you just install a rootkit, there are more protection mechanisms that can detect you. Okay, because you are installing something when you are installing something in the kernel of the operating system, and but it's not a rootkit. It's like if you drop a rootkit using a rootkit, you are actually changing how a machine boots. So if some kind of protection mechanisms annoy you, you can just disable it. Okay, or just disable it between quotes, because the computer is gonna understand that it's enabled, but you have planted some hooks or whatever to just make it work. Okay, so yeah, this is still possible. Okay, answering your question.
Great.
So sorry about the problems. This is like the summary of what I have just said. We're going to use UEFI to improve our bootkit capabilities, downloading files from the internet to during boot, reading the partitions that the disk has, and we're going to use runtime services to plan their own backdoor. That will be what we have code into the DXC runtime driver. And then we're going to implement inside the UEFI bootkit, inside the UEFI application, we're going to implement some hooking and patching techniques to be alive through the entire boot process, okay, through entire boot stages. So from boot to Windows Boot Manager, from Windows Boot Manager to Windows OS Loader, Windows OS Loader to Windows kernel, and at some point we're going to disable some protection mechanisms that we don't want to be enabled, and drop some artifacts in memory. If it's a kernel mod driver, it's better for you. So as I said, the part that truly matters is the rootkit. We are doing funny because we are doing everything here just to drop the rootkit. We are doing it just to have another way of installing the rootkit instead of just using the bring your own vulnerable driver technique to install a kernel mod, to install a malicious kernel mod driver. So we have just got these two bootkits in order to have an alternative way of installation. Okay. But the part that really matters, because this is the element that stays when the user is actually using the machine. So the part that really matters is the rootkit. The thing is, well, we want the rootkit to act autonomously, to operate on its own, but we also want to code. We also want to implement a way of communication. We want to say, hey, kernel mod driver, I want you to do something so specific, some specific operation. So as I said in the previous session, the most common way of communication between a kernel mod driver and an external element, a user mod application in most cases, the most common way of communication is implementing ICTLs and IRPs. We have an isolated proof of concept just for you to understand that kind of communication, just for you to understand each of these techniques. Okay, so just don't worry. But we have implemented other ways of communication, like implementing a keyboard filtering. The driver can catch whatever keystroke you press, and that can be another way of communication, because the driver can act as a driver. The driver can act as a keylogger. And then we have implemented, using the WSK framework, WinSock kernel, we have implemented a way of communication with your own command and control server. It's not finished yet, but you just have to pick the code and add a new, some lines to make the driver be able to communicate with your own command and control server. Okay. Just for you to know that if you really want to implement a way of communication with your kernel mod rootkit, your kernel mod driver, you can use WSK, and in that way you don't need a user mod application. Okay, you can send instructions to the driver using your command and control. And well, in most cases, you're going to develop the driver as a mini filter driver, just as every IDR, because you want to filter operations targeting the file system, and in that way you can hide files, folders, and other stuff. And well, you can implement DCOM techniques to hide processes. You can use the WFP framework to blind IDRs, modify requests, or deny them. And you can remove callbacks to blind IDRs. You can do whatever you want. I'm going to point you to the repository with the proof of concepts that we have shared, the isolated proof of concepts, just for you to understand in detail each technique. okay? And there are comments everywhere, so you're not going to have any problem compiling the proof of concepts and, and developing your own version of the malware. So now I'm going to start with the demo, okay? The first thing I want to do is point you to these 10 repositories related with Bootkits and Rootkits, okay? So in this repository, you have the presentation I'm using now, and the presentation I used in the part 1, and here the YouTube video, okay? Then, as you know, the awesome Bootkits and Rootkits development, here you have in the bookmarks folder, here you have this HTML file that you can import to, do your own research into this area, and there are more than 400. This is not the updated version, this is the dev conversion, but in this one, there are more than 420 resources for you to read, okay? And then we have the Bootkits and Rootkits development environment. Here in the scripts folder, you have some scripts to just, everything you need to install, every requirement, every tool. We have automated everything for you to just execute the script, and just put whatever option you want. So you just have to, let's say that you want to compile the UEFI bootkit or basic proof of concepts of bootkits, UEFI applications, DX0 and drivers, UEFI drivers. You just have to execute this first 4 options. So 1A, enter, 1B, enter, 1C, 1D, and the entire environment is ready for you to compile everything, okay? And then in AVs, here, there is the entire source code for the bootkit. Well, the 2 bootkits, the UEFI application and the DX0 and driver. Here in Ventic, well, Ventic is the kernel mod rootkit, and here you see there is the source code. And as I mentioned in the previous session, here in the Bootkits folder and here in the Rootkits folder, there was information on how to compile your first UEFI application and how to compile your first kernel mod driver in manually, okay, and the proof of concepts. But we have created 2 new repositories, Bootkits development starter pack. Here, if it's your first time, it's good for you to read everything that is here. And in the folder, you see the proof of concepts. And it's the same for rootkits. If you are a beginner, you want to start coding your first kernel mod driver and then start implementing malicious techniques in that kernel mod driver, you just have to follow this GitHub repository, Rootkits development starter pack. Everything is here for you if it's your first time. And here are the proof of concepts, and you have a README for every proof of concept, some information here, and the steps on how to compile it, how to test it in your environment. Okay. So and then we have PK fail. I pointed you to this repository in the last video as a way for you to understand more what secure boot is. And then you have this GitHub repository just for you to know how to start your own UEFI, the UEFI firmware from your computer, and analyze if maybe maybe there is known vulnerabilities in your UEFI firmware and you don't know it, okay? And this GitHub repository is a new one, and we're going to use it because most of the times when we are creating our own environment to exploit vulnerabilities in UEFI applications, we use Camel, and we're going to share um, how to create the environment using Camel. But I think that for beginners, it's better to just create the environment using VMware Workstation, right? So if you just you can follow this like tutorial step by step, and if you follow it and you execute everything that is here, you're going to be able to add your own key into the DB that the virtual machine is going to use, and delete the DBX. So if you delete the DBX, or you delete just a couple of keys in the DBX, you're going to be able to boot some vulnerable UEFI applications in that virtual machine, and you can exploit those some well-known vulnerabilities in those UEFI applications just for you to evade secure boot. Okay, so this is just a good repository for you to kind of emulate that behavior. And I pointed you to this GitHub repository associated with the DEFCON talk that Nikki and Jess, or Jis, I don't know how to pronounce it, made at DEFCON 30. Well, gave at DEFCON 30. And here I think it's in examples. Yeah, here you can find some well-known signed but vulnerable UEFI applications and UEFI drivers, some UEFI elements that you can use to practice exploitation on wherever VMware virtual machine that you have created, if you delete the DBX. Okay, and I think that in the DEFCON talk they showed how they could use some kind of utility in the operating system to update the DBX, but deleting the DBX in fact. And doing that, they could use then these vulnerable UEFI applications to evade secure boot and then install the UEFI bootkit, or or whatever UEFI element you want. So okay, so here I have some. I'm going to power on 2 virtual machines. We're going to work most of the time in this one, in the Windows virtual machine, but I need a Linux machine as well. Okay. The Windows machine has secure boot enabled, and I'm going to show you that CrowdStrike is installed. My password is password, of course. I just want to show you that CrowdStrike is installed here. I'm going to log in into my Linux machine, and
while you're doing that, someone was asking what your thoughts are on the evolution of rootkits for Linux. If you have any thoughts there, no worries if not.
Yeah, I have some thoughts, but that's for 2020. Okay, so I'm not gonna say more than that.
All
Sorry.
right. Coming soon.
Yeah. We're going to just give CrowdStrike a couple of minutes to appear here, just for you to see that it's installed. Okay. Come on, man. Okay, so well, in the meantime, I can explain something. The thing is that I really wanted to give this content, to record this video for the people, because I want everyone to understand that using these resources that you have here, okay, you can emulate an APT that uses UEFI bootkits and kernel mode rootkits. So maybe you work in a company that offers red team. Okay. Maybe you work in a company that offers red team exercises or purple team exercises to other companies. Okay, so just some months ago, there was no open source bootkit for you to use to emulate an APT. So now you can pick the entire malware, the documentation, and to provide that service to the client. It's like, hey, do you want me to emulate an APT? I just want to. You just need to delete some keys in the DBX. I'm going to exploit a known vulnerability to bypass secure boot and load my UEFI bootkit. And my UEFI bootkit is going to load my custom kernel mode rootkit emulating food module, the rootkit that Lazarus uses. And I'm going to test your solutions. I'm going to test your products. I'm going to instruct your teams, to your internal teams, on how this malware and how these threats operate, okay, work. So that's something that I really want you to understand, that using everything that Maria and I have shared this past 2 months, you can like provide this service to other companies, or maybe just do it in your own organization. Okay. So what I'm going to do now is I'm going to open some folder here, some file. I'm going to open this file named, well, the file that is VMX file, because here, this is like the main folder where every single file related with this virtual machine is stored. Okay, so I'm just opening the file to see if this line appears, that means that secure boot is enabled on the machine. But I just want to, and now I just want to pick these 4 lines, and I just want, I just don't want you to see the bootkit and the rootkit running with CrowdStrike installed on the machine. I just want you to reproduce this thing, just for you to have the environment. Okay, so I'm going to add these 2 lines, and with these 2 lines, what I'm gonna say to the virtual machine is, hey, I want you to add a new key to the DB, and with these 2, I say that I want you to delete the DBX. I'm going to use maybe I use some known vulnerabilities that are in a vulnerable UEFI application, and I don't want you to stop me from booting those vulnerable applications. Okay, so now I'm just going to power on the machine again. And just for you to know that here in this repository, I have uploaded these key samples, keys and certificate samples, some UEFI utilities and designed version of those utilities. And if you just need to create your own, you just have to execute this script, this bash script, generate custom keys. We're going to do that. Because I want you to know how to, how to create like your own secure boot infrastructure. So just give me a couple of seconds, and yeah, a new folder is going to be created with new certificates and keys that you can use in your VMware virtual machine, and some UEFI utilities, the normal version and the signed version, and you just want to know how these UEFI utilities are signed. Here at the end of the script, you see the line that is actually signing the UEFI binary. Okay, so we can just copy that. I'm just going to delete this folder because I'm going to sign another UEFI binaries using these certificates. So just I'm going to do that. Just give me a moment because I have to paste line. So let's say that I want to sign some kind of binary.efi. What binary? It's like binary.efi. Binary signed.efi. In a moment, I'm going to come here again and use this line to sign the UEFI application I'm gonna use to infest the machine. Okay, so I just need to write this in correctly. It's okay, so I'm going to return to this point in a moment. Okay, I have power on the machine. I'm going to shut down the machine again, and I'm going to open the VMX file again to see if everything is there. Yeah, so everything is there. Now the next step is deleting the nvram file, and if we power on the machine again, everything is set. We have added our own key to the DB that SecureBoot is using inside this virtual machine, and we have deleted the DBX, so we can use vulnerable UEFI applications and exploit vulnerabilities in those vulnerable UEFI applications in order to evade secure boot and load our own UEFI bootkit. Okay. Well, that's for the third part of the series, but well, whatever. Yeah, you can do that at this stage. So now I'm going to just create a few folders here. Binaries. Going to I'm going to paste some binaries here. I want hello world, key tool, and the shell. And I'm going to copy this script, add boot entry. I'm going to use it to add a new boot entry that is going to be the default boot entry. And so instead of booting Windows in a normal way, I'm going to configure this virtual machine to boot into a UEFI shell first. Okay, just for I'm just creating the environment so you can reproduce it and practice at home. Okay, so I'm going to copy the path and open a PowerShell as an administrator. Yes. CD, quote, paste, quote, enter. Less. And now I'm going to modify this script. As I said, this script is going to take this UEFI binary that is in this folder and I'm going to copy it and paste it in the ESP, the EFI system partition, and it's going to the script is going to use a PowerShell module to add a new boot entry to this VMware, to this virtual machine. And now I have to think about the name of the boot entry, my own UEFI shell. Okay, Control S to save it, and now I can execute the script. It's going to fail, of course, because I have to search this line. That should use. I need to enable the execution of scripts. So I put that line. Yes. And now I can, I'm going to clear and then execute the script. It's going to download PowerShell module. I click yes. And in a moment, it's going to appear here that a new boot entry has been added. Okay. So it has been added. We can confirm that secure boot is enabled, and using this the command get secure boot policy. No, that's secure boot entry. Sorry, that's secure boot. No, get boot. How get boot entry? Get secure boot policy. Get secure boot UEFI. No. Man, how was the command to confirm secure boot file? No, get UEFI boot entry. Sorry, get UEFI boot entry. And here you see that there is a new boot entry added to this virtual machine. So if we shut down the machine and power it on again, we're going to boot into the UEFI shell instead of booting Windows in a normal way. Okay, just for you to know. And now I'm going to open the script again and copy this line. Well, I know that, but I'm gonna copy it. I'm going to mount the ESP again and copy these 3 binaries to the ESP as well. So copy hello world to you colon fi. No thanks. Boot, and I want hello world signed, and I want it to as well. Perfect. So I'm going to dismount the ESP. I'm going to close everything and shut down the machine. Okay, so I have added a new key to the DB. I can sign UEFI binaries with the key that I have created, and I have deleted the DBX in order to just boot vulnerable UEFI applications whenever I want. I could power in a common way, but I want you to see that the UEFI shell is the default boot entry. So you just have to right click on the virtual machine, power onto firmware. And here we're going to see in a moment. I don't know if I can zoom in more. No, I can't. Sorry, guys. So, sorry. Wait, what? The machine is so slow. Sorry for that. Sorry. The machine is slow, so sorry, but I have to reach the option of shut down the system. I'm going to reach it in a moment. Okay. No, now it works. Okay. Because sometimes I have to shut down the machine and power it on again. I have selected the option to boot into the UEFI shell. Sorry, I'm going to repeat that again. I have selected this this option. Click enter, and now I'm going to go to the ESP, CD, UEFI, CD boot, LS, and every single UEFI utilities here for me to test the environment. Of course, hello world.efi is not gonna I cannot boot that UEFI application because it's not signed with a key that is in the DB, and it's not signed by Microsoft. So I can't execute hello world.efi, but I can execute this hello world underscore sign.efi because it's signed with a key that I have said to the client, hey, I need you to add this key for me to emulate the APT, or I need you to delete these keys into the DBX for me to boot into a vulnerable UEFI application, exploit a vulnerability. The third part of this series is going to be about only about vulnerability exploitation. So don't worry if you just you just don't need to exploit some crazy 0-day in the UEFI firmware. Just if you just can emulate and test the malware using just common knowledge. Okay. I'm going to execute the key tool just for you to see that in the DBX has been deleted. I just have added this key. So now if I want, I can copy these vulnerable UEFI applications that Mickey and Jess shared 3 years ago, and I can use them as a way to install my UEFI bootkit. So I'm going to click on exit and exit again and shut down the machine. And now what I'm going to do is power on again, and I'm going to summarize everything. Well, the default entry boot is the UEFI shell, so I have to click on Windows Boot Manager. I'm going to summarize it. I just want everyone to understand that they can provide this kind of service to whatever client they want. Okay, they can use these vulnerable UEFI applications to load their own UEFI bootkit, or they can say to the client, hey, I just want you to add this key to the DB in order for me to be able to boot the UEFI bootkit that I have developed. Okay, I know that my English is not, my English skills are not so sharper at this moment, but well, more or less, I think it's very understandable what I'm trying to do right now.
No, it's great.
Okay, perfect, Steve, thanks. And we have added a few UEFI utilities to the machine just for you to understand how you can, creating your own secure boot infrastructure using this script, and then sign some UEFI utilities, and we're just creating the proper environment to execute what it comes next. So now, well, I'm going to drop here everything I need. So I'm going to create another folder called kernel, and here I'm just going to drop some versions of the UEFI bootkit and the DX0 driver that has been signed with the key that I have added to the DB. This is something so similar to what we did at DEF CON with pkfail in order to just be able to boot or UEFI bootkit in a physical computer that was, that had a PK key that was leaked in a GitHub repository. The pkfail is just the name that binary gave to this kind of flaw. Let's say it in that way. So now I'm just going to drop here some signed versions of both the UEFI application and the DXC runtime driver. And here in kernel folder, I'm just going to drop Ventit, the kernel mode rootkit that we have shared. Okay, but before doing that, we are just going to explain something about the source code. Okay, because in the previous session we didn't have enough time to explain it. I'm going to come here to CDK2. I'm going to open a CMD here. I'm going to minimize it. And well, most of the times, if you just want to compile the UEFI application and the DXC runtime driver, you just have to clone AVs here in the EDK2 folder. Please always place the EDK2 folder here. Okay, if you just use the script, you just use this script, everything's going to be created automatically for you. So the EDK2 framework is going to be in this specific folder, so you just don't have to do anything. But let's say that I want to compile the both bootkits, so I just have to clone AVs here, and well, AVs bootkit pkg is going to be inside here. But first I clone AVs, I execute the command to update the submodules. Okay, submodule, that's recursive, whatever. I don't know the command, sorry. And then I just pick AVs bootkit pkg and move it right here. Okay. And doing that, I just have to come here to conf target.txt and place this line here in the active platform. And yeah, well, it's not, I'm just not, fuck, want, no, this is not a secret. I just leaked it in the previous session. We're just going to create an awesome UEFI vulnerabilities GitHub repository, and we're going to place some well-known CVEs just for you to understand how to exploit those CVEs and bypass secure root. And this one is one of those CVEs. So we just modified the active platform here to put AVs bootkit pkg and this DSC file. And in the DSC file, we can see that here in components, we see that there are two INF files here. So if you compile AVs, ADK setup revealed, see, and then you execute build. Okay, so if you execute these two commands, both the UEFI application and the DXC runtime driver are going to be compiled, and then they are going to appear here in build, AVs bootkit pkg, release, x64, and you're going to find these two files that are the actual UEFI application and the binaries, the UEFI binaries that you need to execute. So we have two bootkits, right? Perfect. Now, the typical UEFI, we have code a typical UEFI bootkit in the UEFI application. Here, this file is the main of the UEFI application. here you see UEFI main. If you want, I'm going to click on view, word wrap. If you want to like debug the bootkit, if you compile it by default with these values, you're not going to see anything on the screen related with, oh, I have just dropped the rootkit in memory, I have just decrypted the configuration. Any message is going to appear either in the console or in in a file. Okay, so if you just need or want to debug the UEFI bootkit, just change the default values for these ones. Okay, so if you do that, it's going to a file is going to be created with everything that the UEFI application has done during the boot process. Okay, just for you to know that this thing can be something that if you are a beginner, you really want to modify in order to see every step that the UEFI application is going to do. So this is a key part for you to modify. Now we have 4 modules. Okay, 4 modules. This one, and this one. The last one is only to boot the operating system. Okay, and the third one is just for, well, it's for we have implemented the hooking and patching techniques in order to modify the boot flow. The entire source code just for you to do that is here in this module. But the first 2 modules are not related with any modification of the boot flow. These modules are just right here for you to understand how you can use the UEFI specification to develop malicious things even without modifying anything. Just encrypting, decrypting, downloading files from the internet, loading another UEFI utilities to drop something into disk, just for you to understand how you can apply the UEFI specification into your UEFI element. Okay, so we have the first bootkit, second one. Here you have some scripts that you can use to install the bootkit, add a new boot entry to the virtual machine. And here you see some Python script. The UEFI application in this first module is only to understand how you can decrypt something. Okay, so how you can decrypt a configuration that has been encrypted and obfuscated. So if we just come to this Python script, here in templates, here you see some JSON file, right? This is the configuration that the UEFI application is going to use, but it's not going to use the JSON file. You have to execute this Python script to encrypt the configuration and then copy the output and paste it in some file that I'm going to point you now inside the first module. Okay, that's how we have developed this thing to work. Okay, so in order to change the behavior of the UEFI application, you just have to read the JSON file. So do you want to display something on the screen? Yeah. I want to show a cool banner. I want to use this image. Yeah. Now, I want to load a UEFI driver that has been created by this guy. I want to use that UFI driver to load, I want to load that UFI driver, and in order to read and write something to the C disk, I want that or no, no, I don't want it. If I can put true here, I can change the value and write true here. And if I do that, I can download the file from the internet or from wherever server I want, or I can drop it into the ESP, because this file is already embedded in the UFI application. I'm going to explain how we have embedded this other UFI utilities in the UFI application. That is in the second module, okay? But well, you just have to change the values here. I don't want any additional component to be written to disk. Now I just don't want to load the DX0 runtime driver. I just want the UFI application to work as a typical UFI bootkit, drop a kernel mode rootkit in memory, and I want to disable DSC as well. Okay, so you just have to change whatever value you want here, and then to come here to the Python script, to open it into an integrated terminal. And please just don't resize this window. That was the mistake I made in the last session, and that was the reason behind behind why the compilation failed, because I resized the window and then some lines disappeared. Okay, so you just don't do that. Okay, I'm going to execute the script. What the fuck? Give me a moment. I'm going to clear the thing and execute it again. I can randomize values. This is going to randomize some values here in the JSON template. And now I'm going to create. Here you could select other templates, but there is only one in the. I have only one here in this folder. So I select the template and I put some password, and I just don't want to resize anything. So I'm just going to click exit and copy everything from the decrypt comment to the end. Okay. I have copied, so I have it in the clipboard, and now I just can close everything. Oh, and here in this .ini file, here you have another things that you can modify in order to change the obfuscation that that we have coded here in the Python script. Okay, so it's just a tool to create an obfuscated and encrypt configuration. Okay. So here in the first module, as I said, there's something related with the decryption of the configuration. Here in the utils folder, you see things related with files, on how to create files in the ESP, obfuscate, decrypt, and JSON. Okay, so, and here in the payloads folder, in this file, payloads default encrypted configuration.c, I'm going to zoom out, sorry, and click on view and word wrap. Here, I just have to paste the configuration that I have created. And now I'm good. Just, well, I could change other things. I'm going to point you to other key parts of the rootkit, of the bootkit now, but for the moment we are just good. I'm going to show you that you can that you can compile the UEFI rootkit. Okay, so we just have to wait a moment. As I said, if you compile the project, both the UEFI application and the DX0 driver are going to compile. But if if the compiler doesn't detect any modifications, well, you're going to have the previous version that you have compiled. So this is one of the key parts for you to know that you need to change, you need to modify the configuration in order for you to modify how the UEFI application works. And here in this second module, here let's say that the first module is just for decrypt the configuration and write the values that you saw in the JSON file to some variables. And now here, based on those variables, we're going to execute some functions or others, okay, based on those files. If something is true or false, or and the source code is here in utils. So you need to resize the screen, you need to print a banner or drop an embedded file into the DSP, if you need to just download something from the internet, if you just need to read or write into the NTFS partition, the entire source code is here in the folder utils, okay? And in payloads, here you see the embedded themes that we can drop into the ESP. So let's say that this guy has uploaded a new version of the UEFI driver that you can use to read and write into the NTFS partition. So you just have to go to his GitHub repository, download the file, and download HXD file, open EFI file, and export the EFI file in the C format. So then you can paste it here, change the length, and this is like the content that you need to paste here in order for you to embed it something that can use in a later stage. Okay. Well, in this case, we use the content of we use this variable, this content here, just to drop the NTFS this UEFI utility in the ESP, and then load it, and then be able to read and write into the NTFS partition. Okay, and it's the same with other additional components that you can drop to disk and images. Well, you can. The thing is that you can embed whatever you need to embed into the UEFI application. Okay, and if you just need the raw things, here are the the raw drivers and images and everything. So the first two modules are just related with the UEFI specification, how to create your own UEFI element to not just modify the boot flow. Okay, and it's if you are a beginner, it's important for you to start deleting the code of these three modules and just understanding how to decrypt the configuration, and then delete only these two and understand how you can use the UEFI specification to do other things. Okay, and the code that modifies the boot flow is here. Okay, here is the code to jump into different boot stages. Here we have uploaded the source code to the hooking of different functions. Then we wanted to disable some protection, so the source code for that is here. And in utils, there is a file here that it's so important. You just have to read. Okay, there are comments everywhere, so you just have to read the comments. As I said before, we're going to locate the specific functions in memory. This function is inside the Windows Boot Manager, but at some point it's going to be loaded in memory. And this is the specific pattern of instructions that we use in order to locate the function in memory. So if you just have enabled this kind of debugging, and you see that some kind of pattern has not been found, you just have to come here. Well, you should you should follow these steps. You should mount the ESP, copy the Windows Boot Manager, and test using IDA if the sequence of bytes appeared in some kind of function, because maybe in that version of the Windows Boot Manager, that pattern is not related with this function. Okay, so you just have to use another pattern of instructions. Okay, so this is a very important file for you to modify. Okay, at some point, because maybe you need to modify it because in your Windows Boot Manager version or in your Windows OS loader version, this pattern doesn't exist for the function that we want to locate, okay, and then modify it with our custom version of the function. And then I think it's here. No, in payloads. Sorry, I'm going to close that. Then here in payloads, in this .c file, you see the content of something here. This is the content of the kernel mode driver that the UEFI application is going to drop. It's going to map in memory. Okay, so if you want to, if you want the UEFI application to drop another kernel mode driver in memory, you just have to change this content. Okay, and please just read how to generate the content from a sys file. Okay, you just have to read how to do that. And I think that's everything for the UEFI application. I think I have pointed you to the important parts of the source code that at some point you can modify. So we're going to continue. Okay.
I got one question, very specific question on some of the source code that you posted. It is, how does modifying the value being moved into ECX associated with the C initialize affect CI.dll's internal state during early boot? And what specific field or structure inside the code integrity policy is being zeroed out? It's pretty specific.
Yeah. Can you send me the question in the chat? Or
yeah, I'm going to post it right now. Here it comes.
It's so long,
right?
And I don't know how to approach it.
There it is.
Is being okay. So how does modifying the move ECX value instructions associated with scene affect CIDLLs? How does modifying the move one instruction created with early boot? Give me a moment. Have to think.
They were looking at the file for protections driver signature enforcement.
For protections driver signature, yeah, this one, yeah. I'm going to click view, war wrap, and locate. And how How does modifying the move ECX where I do that? X move ECX look to assembly. It's solder, right? Yeah.
Yeah, looks like it. Yeah.
Look to this and process instructions. Reject something, countering the others of the instruction in memory. It's writes. While we move to this ECX register, while remove instruction. This is just final draw and then jump else. Wait, give me a moment. I want to see the if else, then the else jumper call. Through the hours of terror and initialize stores the address of move instruction related to C initialize. Okay, so and then the question is how does modifying the move ECX value instructions related to C of X CI.dls internal state in early boot and what specific field of structure inside the code integrity policy? You're just changing the value that some function returns to you. So that's why you change some value of the register just for, let's say that the function should return you a 1, some kind of value. So you are changing the register in the exact point. You are changing the value of the register at the exact point just to disable the protection. You just need to do that, changing the value of the register. Okay. And what specific field of structure inside the code integrity policy is being seried out by replacing with short ECX. I think I say that here, set ECX to 0. Use, everything is here for you to read. But yeah, I'm just like changing the value of a register, and the value of that register at some point is the value that the function is returning. So if you change that, you are changing the state of the protection. Okay, yeah. You just cannot read the it's just only 200 lines, and if you have something that you don't understand, just send me or Maria a message through LinkedIn, and we can make a video call or something just for you to understand it. Okay, so don't worry about it. First you just read it, and if you don't understand it, just send me a message. Okay.
Yep, no, it's awesome. Great question. I like that somebody's really getting into the weeds there and the details.
Yeah.
One last question real quickly. Someone was asking about hyperjacking and your thoughts on that.
Hypervisor?
Yeah, like, shimming in, somehow getting a hypervisor to boot up instead of Hyper-V, like getting in between there.
We didn't test that, so I'm not going to sure if if you isolate the kernel completely, and there are some protections to do that. The thing is that how it was called, Black Lotus. How Black Lotus was installed. The thing it was installed using some tool, but that tool disabled some protections. For example, it disabled BitLocker if it was on. So, and it could disable another protections that could block the UEFI bootkit to boot. So the thing is that when you are installing the UEFI bootkit, you are disabling everything that you cannot bypass. Okay, everything that you cannot disable. Okay, so that's how it works. Maybe I don't know the exact question that you can patch Windows, but that's another question. Yeah, you can patch Windows boot MDR, so you can run your own hypervisor, and when you don't want to handle and interrupt, or VM exit yourself, you can pass it back to the hypervisor. That's so cool. Can you send me a message through LinkedIn? And I want to research that because I'm not into hypervisors, so I would like to research it by myself. But
Cool.
yeah,
Yeah, shoot
that's so.
Alejandro a message on LinkedIn, and we'll have another
Yeah,
session.
yeah. Please send me your questions and those kind of interesting questions. I didn't know that you could do that, so um, please instruct me on how to do that.
All right, I'll let you get back into the flow. We'll do some Q&A at the end, of course. So
Okay, thanks. So yeah, well, I think we have seen like the key parts of the UEFI application, and here you have the DX0 runtime driver, and inside the DX0 runtime driver, there is the user mode application that you can use to communicate with those runtime services that the DX0 runtime driver has modified. So you use this user mode application, this one right here, to communicate with those runtime services and drop a rootkit in memory. Okay, so there are comments everywhere. You just don't need to modify anything in the DXR runtime driver. Okay, and now I want to see the source code of. Well, I'm not going to see the source code, but I'm going to explain a few things about kernel mode driver. But I'm going to open the GitHub repository because you are going to see that better here. Okay, so here in Bootkits Rootkits, there is the source code. And as I said, we have coded a user mode application to communicate with the kernel mode driver. Everything is, every source code that you need is here. Okay, but at some subfolder here in functions and techniques, here you have the techniques that we have implemented. Well, we have to update, we have to upload the updated, the new version with the technique on how to remove callbacks and blind IDRs. But if you just have to add your own technique here, you just have to add two files and then locate where it is. No, now CTL, but this is the .h. I need the .c file. Let's say that you have added a new technique here, the .c file, the .h. You just have to maintain the same structure that you see here for everything to work. And here, at some point, you see some switch case, and based on the IOCTL that the user mode application is sending to the kernel mode driver, you execute some technique or other. In this case, you execute techniques, the kernel object manipulation, hide something, hide some process. And I want to see something here, because here, you see that there is something here hard-coded. Well, you just need to understand more about the direct kernel object manipulation technique. Well, you just have to come here to the awesome GitHub repositories, and you just have to go to rootkits, techniques, and here you have some more information on basics, proof of concepts, and we have an isolated proof of concept just for you to understand the decom technique, just here with a user mode application and a kernel mode driver to send the operation of hiding a process. And here we have something hard coded as well, right? Where is it? 0x here. Okay, so here in the function to hide the process, we have hard-coded 2 offsets. So if you are in, in another version, well, I have tested in 24 and 25, but maybe if you are using the 22.82 version of Windows, you have to update these hard-coded offsets, because these are the offsets that we are going to use in order to modify some structures. So this is one of the files, one of the things that you need to change in order to make the kernel mode rootkit work in other versions of Windows. At least this technique. The other techniques are, we haven't hard coded anything, but there are some well-known techniques in which you where you modify some kernel structures. You don't know something about kernel structures, you just have to visit the Virgilius project, explore kernels, x64, Windows 11, 25, and here you see some structures, and you can, just see how the structure is structured. Or you can pick WinDBG and debugging the kernel, you can see the structure and see the offsets. But well, in the rootkit, this is one of the key parts that you need to change in order to make the rootkit work in other Windows versions. Okay, just for you to know. So we can build it, and we have already built the APTs bootkit, the UEFI application and the DX driver. So now I'm going to copy wherever I need the rootkit and the bootkit to just to emulate the APT, right? So just give me a moment. Oh well, and this file right here, the dv there and dvx there. Well, I have copied from here, from the output of the bash script. So now I'm going to come here, and I'm going to copy the user mode application that we use to communicate with the kernel mode driver and the kernel mode driver as well. And I'm going to copy, and this one is so funny. Just give me a minute. Here in the third module in payloads raw, we have uploaded a few drivers, compiled drivers, and some user mod applications to communicate with them as well. And I'm going to show you something funny just in a moment with these things. Okay. The UEFI application is going to drop a basic kernel mod driver in memory, and using this user mod application, I'm going to be able to communicate with the kernel mod driver to load this rootkit, Ventic, or wherever rootkit you want. And then I'm just going to copy the I suggest no, I'm not going to copy this one. I'm going to copy this one, and yeah, and I think that just it, right? Yeah. And now I just can, and now I just can copy these 2 files, okay, to the Ubuntu machine, the UEFI application and the DX runtime driver, and I can sign them one. That is one. Using the key that I have added to the DB. And I have to do that because it's the way I'm booting these UEFI elements, just adding a key to the DB, okay? The class where we are going to exploit vulnerability is going to be the next one, okay? I just want everyone to understand that they can pick the malware and, just provide the fucking service of emulating an APT. So, now I'm just going to open here a terminal, and I'm going to wait to create here a server. I'm just going to download those files to here. To open Google Chrome, and if I'm not wrong, this is going to be the IP address. Yes, it is the IP address. I'm going to keep the files, this one and this one. Okay. So now to copy them to this folder, UEFI binaries. And I could use this PowerShell script to just create another boot entry to boot the UEFI application, and it's going to work. But I'm going to do it in other way, just for you to know how you can do it manually without using the PowerShell script, okay? Because we have done it, we have using it in a couple of minutes ago to create the boot entry with this shell. So now I'm just going to do it manually, just for you to understand that you can do it like this if you want as well. So I'm just going to mount the ESP, and I'm just going to go to this folder and copy the UEFI application and the DX0 runtime driver to the ESP. Okay. Well, just going to copy this one. Okay. So now everything is ready for me to use it. I'm going to shut down the machine, and we're going to, we haven't used the PowerShell script because I want you to see how you can create the boot entry manually. Okay, so we just have to come here, right click, power onto firmware, and we're going to click on enter setup, configure boot options. We're going to add a new boot option with EFI boot, and I'm going to set this one because I want the UEFI application to boot. And I'm going to write here some name. It is UEFI application. And sorry, the machine is so slow. Just give me a moment, okay? Okay, now I can change this on exit, and I have created a new boot entry. Okay, so if you just don't want to use the PowerShell script, you just can do it manually, okay, this way. Well, I guess it's something that it's basic for most of the people here, but just for everyone to know. And now I can click on this option, and the UEFI application is going to modify the entire boot flow. it's going to drop the rootkit in memory. So now there is something in memory that there is no solution out there. Well, there is one, but I'm going to point you to that solution in a moment. But there is no well-known solution that can stop something that is in the kernel of the operating system. And the UEFI application has modified entire boot flow to just drop something, that dropped some kernel mod driver into memory. So now I need, well, you can use this PowerShell script to download the sysinternal suite tools, but I'm going to download it manually. Oh, wait. So download sysinternal tools. Going to extract it here. Then I'm going to use DVG view. Want to sort by none. What, Steve?
Oh no, I was gonna say the Virgilius project, such an amazing resource.
Oh yeah, absolutely. It's the best one. Well, there is something even better than using Virgilius project.
The brain?
No, it's like find it yourself how is the structure using WinDVD.
That's what I was saying. Use the brain, yeah.
yeah.
WinBindex and Virgilius are two sites I'm often on.
Yeah, Windex. Yeah, I have that web page in the Awesome GitHub repository as well. Just to show you that the UEFI application has dropped some kernel mod driver in memory, I'm going to open the dvgview64.exe tool as an administrator. I click on yes, and now I have to make sure that these two options, capture kernel and enable verbose kernel output, are enabled. I'm going to close, and I'm going to run again as an administrator. These two options are enabled, so we are good to go. And now I'm just going to I'm just going to use this tool to say hello to the kernel mod driver that the UEFI application has mapped in memory. Okay, and it's there. It's some part of the memory there, just waiting for us to send it more instructions. Okay, so, and well, I explained this in the last video. We just wanted the UEFI application to drop a basic kernel mod driver in memory, for you to have that basic kernel mod driver in memory and be able to load not just Ventic, but whatever rootkit you developed. Okay, and now what I'm going to do is communicating with. I'm just going to communicate with the kernel mod driver and say, hey, I want you to load this rootkit. Okay, so now that we have, CLS, and now that we have load or rootkit, we can do some cool things, right? Like I'm going to execute techniques and list all to see the options, every command that I can execute. I'm just going to zoom out, sorry. And here we have structured the techniques. Based on we have structured every command based on the technique it's related on. So DCOM, keyboard filter, NSI, WFP, WSK, mini filter, and now in the new version callbacks. But whatever. So I'm going to say hello to the rootkit, okay, and I'm just going to do the most the thing that almost every every solution should detect, like hiding a process. Okay, I'm just going to hide the paint process. Okay, so wait, just give me a second because I have some music sound here. Okay, sorry about it. I'm going to execute task list, and the speed of the process is 3180, right? So now I just can communicate with rootkit using this user mod application and say, hey, I want you to hide this process. Okay, so you can see that paint is here in the task manager, right? When just give me a moment. And I just want to open, CrowdStrike's here, wherever, having an IDR installed, it doesn't do anything. It's like, what the fuck? And the process disappeared, right? And we can list hidden processes, right? Or list hidden processes, and we have unhide. We have one process hidden. We can hide it in this way using only, specifying only the index. Okay, so can hide process 0, and the process appears again, right? This is just something so basic. And we can I don't know, we can create a folder or a file and hide it using this command. We just come here again and reload. The folder is going to disappear, and we can hide folder again. The folder is there, and the process is there, but there is something kernel space that doesn't allow you to see it. And you can do the same with network connections. You can block connections. You can enable the keylogger. So keylogger on, and if I open again the view, you're gonna see that it captures wherever keystroke I press, right? And to turn off the keylogger, and that's that's it. You can emulate an APT using a UEFI bootkit to drop a rootkit in memory. You just have to tell the client, hey, I'm going to use this signed but vulnerable UEFI applications that Mickey and Jess shared at DEFCON 30. So I want you to delete these specific keys in DDBX because I need to bypass secure boot to load my own UEFI bootkit. Or maybe you can say, hey man, I just need you to add this this key to the DB because I'm going to emulate an APT. The APT is going to find a 0-day in a UEFI application, maybe you are a company, you don't have time to do that. So you can just say the client that and create your own version of Avis, create your own version of Ventic, and just, if you install a UEFI rootkit, it's not like a rootkit. It's not like a rootkit. A rootkit can be detected, but a UEFI rootkit, it's more complicated. You can even use only a UEFI application without dropping a kernel mode driver in memory. You can just use a UEFI application to download files from the internet, some malicious files from the internet each time the machine boots, and drops them to disk, for example, and see if the client's team can detect what happens in that machine, right? And don't leave, because I'm going to do more things, and I'm going to point you to some companies. Well, if you just want to learn more things about UEFI, you just have to check the blogs, the binary list blog, or Clipsune. Clipsune. And if you are looking for a company that can, or at least have some kind of product or agent to detect that a UEFI bootkit or a kernel mode rootkit has been installed on the machine, you can pin these guys from Invari. I met Jason, the CEO of Invari at DEF CON, and I know that they are using an NSA licensed technology to build their solution. So you can give them a try if you just have a machine that cannot be vulnerable in. You just don't want the machine to be vulnerable in any way, because you are storing there so some critical documents. And these guys try to find if the integrity of the machine has been compromised using that technology. There are some graphs involved. Well, it's a licensed technology. I think there is some paper out there, but I'm not sure. I think it is, at least the basics of the technology. But well, and then as I said in the previous video, there is a guy. I'm not affiliated with this guy in any way, associated with this guy in any way, but it's Black Friday, and he's selling a professional rootkit. Well, some license for lifetime. So if you just want to give it a try, you just can contact him. The thing is, I know for sure that the way he drops the rootkit is using the bring your own vulnerable driver technique. So he's going to give you a few 0 days, or at least some exploits for not so well-known drivers that has vulnerabilities. Okay, and don't leave, because we have to do something. We have to do other thing now. I'm just going to close everything, shut down the machine, and after the talk we gave at DEF CON, we found ourselves in the middle of some kind of masterclass with the people there, and we explained them why we developed the DX0 anti driver in first place. Okay, and we have developed the DX0 anti driver, and I'm going to load it. Okay, cd fi cd boot less I'm going to load the DXC runtime driver. Now we just have to wait a few seconds, and I'm just going to cd Microsoft cd boot mgf.w.efi to boot the Windows boot manager. I have just loaded the DXC runtime driver and then load Windows in the normal way. And we explained to that people that we developed the DXC runtime driver first because we wanted to see if something in the mapping process of the kernel mod driver failed or not. The thing is that we know that the UEFI application is going to map the kernel mod driver in memory, but something in those reimports and reapplications, something can fail. Okay, but if we use the DXC runtime driver to map a kernel mod driver in memory, we're going to see if something fails because we are here. Okay, so now I'm just going to I'm just going to copy. I think I have just flagged another. I have just leaked another future projects, but no, it doesn't matter. Now what I'm gonna do is using using how it's called Bootkits 2. Okay, I'm gonna use this user mod application in order to just that's the thing. You have to execute this user mod application as an administrator to be able to communicate with the DXC runtime driver. You just don't have to do that if you use the UEFI application. Okay, just for you to know. But we can. You need administrator privileges or physical access to deploy the UEFI bootkit. So, whatever. I'm just going to check the presence of the DXC runtime driver. The DXC runtime driver is there. Well, we have loaded it. And now what I'm going to do, just for you to see that, oh man, I just don't want to group. I just want the name. Okay. You can communicate with those runtime services, and those runtime services have been modified in order for you to just communicate with them and execute wherever code you want, shell codes, or mapping, or you can map another kernel, a kernel mod driver in memory. I'm going to just do that in a moment. Give me a moment. Load, and then I'm going to just load this one in memory. Okay, I'm just going to load this kernel mod driver in memory. And as you can see here, we see the reapplications or reimports that we have to. I want to zoom in. What the fuck, man? Well, okay, so now I'm zooming in. So I'm just seeing the if everything has been imported successfully. The thing is that first we have coded the DXC runtime driver for us to see if something failed in the mapping process in memory, and then we finished the UEFI application, because the code to map the kernel mod driver is the same in the UEFI application and in the DXC runtime driver. So if we use the DX, we can use the DX runtime driver to see if something has failed, and if something has failed, we can solve it here. Maybe there is some external library that we don't know where it is, and we can use some functions, so we can realize of that and change the kernel mode driver. Okay, just I needed to explain that because I just said that in the master class we did at DEF CON. And yeah, now we have a kernel mode driver in memory saying hello, hello, hello. That could be a rootkit, or that could be whatever you want. And the IDR is installed. It doesn't matter. It's like it's you are infecting the machine with the most advanced malware that you can actually code and installed on the machine. So unless you have something so specific looking for what the UFI application, what the UFI bootkit is going to do, it's like you are done. And as I said, you have every resource that you need to emulate this behavior. Okay, some months ago you couldn't do that. Now every company, every organization out there can pick these resources and test their solutions, test their teams, and just emulate how an APT works, because how an APT operates. Well, an APT that uses bootkits or rootkits, and you just can come here and say, okay, so what the Lazarus uses? I'm going to mimic the behavior of food module. I know that they use the bring their own vulnerable driver technique. They use this CVE to exploit a vulnerability in a kernel mode driver and load their own malicious kernel mode driver, but I'm going to do it in other ways. So I can just come here and say, okay, so the kernel mode rootkit called food module, what kind of operations implements? So something with register callbacks, object callbacks, or I guess they remove callbacks to blind IDRs. So typical, so common. Okay, and then mini filter driver, of course, and Windows filtering platform to modify requests. Well, you can just see and read wherever blog about wherever rootkit, and using the bootkit and using the resources, you can emulate the behavior, right? And I'm just so I'm so proud of what Maria and I have just built and shared with everyone, because some months ago you couldn't do that unless you have something in your team so skilled, right? So, and now you can provide the service. And I wanted to do that this way. I just don't want you to, oh, okay, so he said I have to follow this step by step for me to create the environment. No, I just wanted to do that for you to, trust me that you can emulate the behavior using the resources. And I think that's all that I have that I that I have prepared for today. Yeah, well, in 2026 we're going to do another part. Maybe you can ask Steve about it. Just exploiting vulnerabilities to see for you to understand how you can detect those vulnerabilities in UFI applications, UFI elements, and how you can apply some techniques to exploit them and create the environment you need. Everything related with exploitation. Okay, and well, give me a moment, because I have the presentation here, and well, you already know that these are the resources. Okay, so the awesome resources and the starter pack, the bootkit and the rootkit, and how to create the environment for you to just start developing, compiling, exploiting, wherever you want. Okay, so yeah, I think that's all. More or less, I think it was understandable. I hope so. Sorry if I'm not speaking English so well. I'm in the middle of trying to improve it. But if you have any poking question, just send me the question through LinkedIn to me or Maria, and I'm going to gladly answer it. And uh, some guy has written to me a few. Well, he wrote me like 1 or 2 weeks ago, and my life, I was involved in different projects, so I couldn't make a video call with him, but I'm gonna make it the next week. So just for you to know that I'm very accessible. Okay, I think that's a word that exists. So I'm very accessible. You can call me, you can send me a message, and I'm going to answer it back. Okay.
That's
And
very.
I don't know if there are some other
There's
questions.
there's a bunch of questions. I'll have to go back through and look for some. If you had a question
Okay.
earlier on and we didn't get to it, go ahead and feel free to post it now. But thank you so much, Alejandro, to you and Maria, of course. Very, very kind of you, sharing a ton of information. And again, your preps and links and everything else is fantastic. So thank you so much for that. And always be careful what you wish for. If you offer to let people contact you, sometimes it can come in.
Yeah,
Um,
well,
I think I think you wanted to give a birthday shout out too, didn't you?
yeah. Well, I don't know if my mom and my dad are sleeping right now, but well, maybe they are listening. Well, they don't speak English, so I'm gonna say it in Spanish. Well, in Galician. So it's my dad's birthday, and I'm gonna wish him a good birthday. So, hey pa, ma, non sei se estades escoitando isto, pero bueno, se o estades escoitando, pa, que te quero moito e que feliz cumpleaños e que nos vemos en Navidad, vale? Que antes creo que non podo ir. Quérote moito. And that's it.
Happy birthday.
Yeah, happy birthday.
Let me try to grab a couple here. Let's see here. Yeah, lots of people asking about Linux rootkit stuff in the future, hopefully.
Don't worry about it. No questions about it.
Someone said, can you show, not necessarily right this second, but can you show a C2 connection with the rootkit? That I think they said you did at
We
the
ha-
DEF CON talk.
we haven't implemented, well, I have to shut down the machine again. We have not implemented a complete command and control. It's just the code for you to, well, not for you, but it's the code for the driver to communicate with some page. I don't know if it's Google or wherever web page out there, and receive a response, right? Or receive like an answer. So you just have to add a few lines to that in order to create your own command and control within the driver. But we haven't coded an actual command and control. It's just, how to send the requests. And with that information, you can, instead of using the user mode application to communicate with the kernel mode driver, you can pick the answer that you receive from that website, from that web server, and say, hey, I want to hide this process. Okay, I'm going to execute it. And that's it. You just have to add some new lines to that. Okay. But well, if you want to see it, I can, it's just making a request to the internet. I just have to power on, execute UEFI application, and I can show you that in just 1 minute. Okay.
And someone was commenting maybe in the future showing some rootkit anti-forensic techniques like removing it from the unloaded module list.
Well, there are definitely some techniques out there to, just hide your activity even more and test the activity. The thing is that you are not coding a UEFI bootkit. You are not developing a UEFI bootkit. You are developing an element to boot your machine. So you have to understand how to boot your machine. And when it comes to rootkits, you are not coding a kernel mod driver. You are coding some kind of element in the Windows kernel. You are coding an IDR sensor, for example. You can think that it's like this is the most advanced malware you can actually develop, because this is not an external application. This is not a ransomware, a Trojan. It's not like that. It's just without bootkits and rootkits, you couldn't use your machine because you couldn't boot and you couldn't, the operating system cannot exist without kernel components. That's the thing. Give me a moment. I have to open a CMD here and say mapper load antique. Sorry. 2. No, antique 21. List all. Sorry. List all. Zoom out. Going to maximize this and key enable C2. Going to do that. Downloads just for you to see, because it's so simple. We haven't dedicated our time to just code an entire command and control. It's just enabling the command and control. Oh well, you have to see if the kernel mod rootkit is there, and then you can execute commands. So it's just drop in the web page doesn't exist, sorry, but you're just sending the request and receiving the response, just for you to understand that the kernel mod driver can make requests by its own. Okay, so and then you just have to add new code to make this thing the main way of communication, just like that. While enable the C2 is going to make the request again and again and again. I think every 30 seconds or something like that, and I can save it as well.
Great.
Oh, sorry. Okay. Disable C2. Okay, just like that. And are there more questions?
Yeah, well, one is, will the technique you demonstrated be able to compromise security projects that replace UEFI and BIOS like core boot?
Yeah, and the question is?
The question is, will this technique or the techniques you showed be able to compromise security projects like core boot, if you're familiar?
Like compromise core boot. It's like, and you are talking about some protection mechanisms that I haven't done my research into them, so I don't know how core boot works at the moment. Just give me some time, and I'm just gonna do it. Give me time.
Some of these questions might be more specific to the context you were in at that moment in time, but someone asked, what are the possibilities of using EFI NVRAM variables?
What are the possibility of using them, NVRAM variables?
Yeah.
Well, you can modify them. The thing with I deleted the .nvram file, because in that file it's stored the variables that are used by secure boot. So that's why I deleted it, in order to recreate the in order to recreate the file. So you can open that file with some tool and see that the DB that I have added the DB and deleted the DBX. So the possibilities with the NVRAM files are that in those files, the secure boot configuration is stored. Well, configuration, some keys are stored, and you can modify the files in order to change the keys, the databases that are used, and the variables. You can create your own UFI variable, and it's gonna be appear there.
Yep, cool. We'll do this last question here, and then I will let you go because I know it's getting late for you. Which debugger do you use to debug UEFI applications?
Don't worry, everything is gonna. Yeah, because you're asking some questions about future projects. So don't worry, we're going to be here for so long, and we are not the guys that say, either Miami. We are not going to be the guys that goes to a conference and say, "Hey, I have discovered this thing. Look at my fucking face. I'm not give a fuck." It's like, give me the code, give me examples, give me something. It's like I don't want you to talk about what you have done. I don't give a fuck about that. Give me at least some resources for me to research the topic. Okay, so don't worry, everything's gonna be shared at the right moment. Okay, that's I think that's a good answer.
Cool. All right. Well, for anybody else with questions, please go ahead and post them up on YouTube, and we'll take a look at them afterward. This is about to, like, as soon as we end this stream, it'll be on YouTube. And like I said earlier, I'm going to give a Off by One shirt away to just a random comment that's there. So probably tomorrow at some point, I'll check the feed or video and see what's there, pick a winner, I'll respond to it, and we'll send a shirt out to that person. I'll also tweet that. Just one last thing. Next week's stream, we have Bramwell coming back on with a session called Can't Stop the ROP, Weaponizing Return-Oriented Programming on Windows to Bypass System DLLs. This is all about high entropy ASLR and that type of stuff. So definitely check it out next Friday at 11 a.m. Pacific time. We will be on with Bramwell. But thank you so much, Alejandro. I love having you on, and absolutely, whenever you're ready to come on again, I'm sure people would love to see you.
I love to be here, Steve. Oh, I can I say another thing?
Yeah.
The 17th of January, I'm going to give another talk for a DEF CON group named DCG 518. I think they are hosted in New York, and I don't know if they are going to publish the content, but it's going to be about like how to get your first CVE and introducing yourself into binary exploitation. So I need to check if it's gonna be live, but well, if it's live, I'm going to write a post on LinkedIn so you can check it. Okay, that's the nearest thing I'm going to do.
Yeah, send me the info and I'll tweet it out for sure.
Perfect. Thank you so much, Steve.
Awesome.
And Randall as well.
Well, thank you, everyone. Have a great weekend. We will see you next Friday. Talk to you soon. Bye-bye. Thank you.